Hi folks, we're going to take a look at question 15 on page 36. So let's take a look at the question here. A pilot wishes to reach an airport 350 kilometers from his present position at a heading of north 60 degrees east. Okay, so this is telling us where the plane has to actually fly. So this would represent the ground velocity, okay, our resultant velocity. This is where the plane actually has to fly. So in order to get that resultant velocity, what we do is we're going to add the air velocity of the airplane, so the direction and magnitude that the pilot actually steers the plane, and to that we add the wind velocity to give us our resultant, which is this in this direction here. So we're given that the wind is coming from south 25 degrees east. So let's make sure we read that carefully. This is where it's coming from. It's coming from south 25 degrees east. That means it's going toward the opposite direction. It's actually moving toward north 25 degrees west. Okay, and they give us the magnitude, 73 kilometers per hour, and we're given that the plane has an airspeed of 450 kilometers per hour. So that's the magnitude of the air velocity. And with that, we need to calculate these things here. Okay, so we'll start by getting, as usual, as good a diagram as we can. So we know the direction of our resultant velocity. So I'm going to start with that here. So start with my compass, and that has to be north 60 degrees in the east direction. So let's draw a vector there. Make it a nice big drawing. So here we have 60 degrees. Okay, and this is our resultant. This is our ground velocity. So in order to achieve this resultant, we need to add together the air and the wind velocity. In this question here, the wind is given to us both the magnitude and direction. So I'm going to draw that one first because it's the easier one to draw. So I know that that's going to be going towards north 25 degrees west. So let's draw this here, north 25 degrees west. So it'll look something like this. And this is 25. And to this wind velocity, I'm going to add the air velocity to give me my resultant ground velocity. So this is going to be the air velocity. Okay, and let's add in the information we have. So not only did we have the direction of the wind, we also know its magnitude is 73. Okay, and we know the magnitude of the air velocity is 450 kilometers per hour. So the first thing they're asking us to find is the heading the pilot should steer. So this is where he's steering the plane, meaning the direction of the air velocity. So we're looking for the direction of this vector here. So right off the bat, I'll place compass plane at the tail of the air velocity. So ideally, what I'd like to do is find this angle here. Let's call it alpha. Okay, because then I could say it's east this many degrees north. Okay, but that's not a part of my triangle, so what I'm going to do instead is find the angle in the triangle that has a relationship to this alpha here. So we'll call this beta. Okay. Now why is that useful? Because if I extend this line here, this north-south, till I hit this east-west, well, these are going to be perpendicular to each other. So if this is 25 degrees, that angle in here, okay, just that little portion will be 65 degrees. So if I find beta, I can subtract 65 to get alpha, which is what I'm looking for. So let's start by finding this angle here. So I see that I can determine that large angle in the triangle because I know this is 60, that's 25 for a total of 85. So I know this angle and I know its opposite side. Okay, so this tells me that I would probably be using the sine law. But the other side that I know, the 73, is opposite to this angle. Okay, I don't have the side opposite to my angle beta, so I'm going to have to find this angle gamma first, which is fine because once I know these two angles, I can find the one that I'm missing. Okay, so let's start looking for gamma. So we've got sine of gamma over its opposite side, 73, is equal to, and now we use our known pair, sine of 85 is over 450. Okay, so gamma is going to be equal to sine inverse. Okay, and we just bring that 73 to the other side first. So 73 sine 85 over 450. Okay, so let's calculate that quickly here. Make sure you're doing it correctly on your calculator. So sine inverse of 73 times sine 85, close the bracket there, divided by 450, and we've got 9.3 degrees. So if this is 9.3 degrees, I'm now going to find beta, which is 180, minus 85, minus gamma, which is 9.3. So let's find beta. So we have 180 minus 85 minus 9.3 is equal to 85.7. Okay, so beta is equal to 85.7 degrees. So let's go backwards now. We know that this angle beta is 85.7. This portion we know is equal to 65, so we subtract to find alpha. So alpha is equal to 85.7 minus 65, and that'll just be 20.7 degrees. Okay, so now we can answer part A. So the heading of the plane should be, well, it's going to be east 20.7 degrees north. East 27 degrees north. Okay, let's take a look at B. So B asks us to find the ground speed of the plane, meaning we have to find the magnitude of this vector here. So again, we've got lots of information. I think we can probably use sine law again. So we use magnitude of VG over the sine of its opposite angle, which now I know is that beta, 85.7, equal to, and I'll use my known pair here, 450 over sine of 85. Now, by the way, I notice that these two angles are almost identical. This is 85, that's 85.7, so this is almost an isosceles triangle. So I should expect VG to be very close to 450. So that's just a way to see if my answer makes sense. Okay, if it's far off, then probably know I did something wrong. So here VG, okay, is just equal to 450 times sine 85.7 over sine 85. Okay, and let's see what happens. So we've got 450 times sine 85.7 divided by sine 85, and we have, not surprisingly, something very close to 450, 450.45. Okay. So here we were looking for the ground speed, which is just the magnitude of our ground velocity, so that's equal to 450.45 kilometers per hour. Okay, the last thing they want us to find is how many minutes it will take for the plane to reach its destination. Okay, well now I know the velocity that it's going to be traveling at. Okay, and I'm told early on in the question that the airport is 350 kilometers away. Okay, so in C, we know that the distance is equal to 350 kilometers. Okay, we know that the speed is, notice here, I don't have the, oops, let me make sure you can see that here. We have the distance 350 kilometers away. Speed, notice I don't have the arrow above it, so I use V for the speed, is, we know, 450.45 kilometers per hour. Okay, so this is the speed it's actually traveling at, and the relationship between speed, distance, and time, of course, is V equals D over T. But I need to find the time, so I isolate the T, so multiply the T, divide the V. T is equal to distance over velocity. Okay, so we have the distance of 350 over the velocity of 450.45. Let's calculate that. So 350 divided by 450.45 equal to 0.777. I'll keep that third decimal place. So that's 0.777, but since this was kilometers per hour, this is 0.777 hours. They would like the time in minutes. So in order to have it in minutes, this is 0.777 of 1 hour, so we'll multiply that by 60 minutes. Okay, so take this here, multiply it by 60, and we get 46.62 minutes. Okay, so we see here that we can use our information about velocity to find other values, in this case here, the time. So just a recap of important things is make sure that when you're reading your question, you can determine which is your resultant velocity, your ground velocity, because that means it is going to be the sum of two other vectors. So in the case of a plane, it'll be the airspeed and the added to the the wind speed added to the airspeed. In a boat question, it might be the current speed added to the speed of the boat itself to give you a resultant velocity. Okay, that's it for now.